Hello and welcome back to the course on machine learning. We've already talked about hierarchical clustering and how the algorithm works. Also, we talked about dendrograms and how they are constructed. Today, we're going to put the two together and learn how to get the maximum value out of our hierarchical clustering algorithms. So let's get straight into it. All right, so here we've got an example. The example that we looked at previously, where on the left we've got the points in our scatter plot, and then here on the right we've got the dendrogram which contains memory of how the clusters were formed during the hierarchical clustering algorithm. So here we can tell right away from, first of all, P2 and P3 were combined into a cluster. Then because their height is the lowest, the height of this bar is the lowest, then we look at the next lowest bar is this one. So P5 and P6 are the least dissimilar out of the remaining. And then these are pretty much the same height, but we first performed clustering. We combined these into one cluster. So P1 was added to cluster P2, P3, then P4 was added to cluster P5, P6, and then at the end, all of the points were combined into one cluster. So that's what the dendrogram is telling us. As you can see right away, it's giving us a lot of additional information on top of the scatter plot, and it contains that memory of the hierarchical clustering algorithm. So how do we use this dendrogram to understand how to best execute or get the most value out of the HC? So let's have a look. What we need to do with the dendrogram, or what we can do, is look at horizontal levels and set thresholds. So we can set height thresholds or distance thresholds, or also called dissimilarity thresholds, because this vertical axis measures the Euclidean distance between points, which also represents the dissimilarity between them, or points or clusters. So what we can do is set a threshold for our dissimilarity, and we can say that we don't want dissimilarity to be greater than this level. So again, it doesn't matter what the absolute value is, it matters what the relative value is and how it looks on this image. So we're setting the dissimilarity threshold, and we're saying that anything, if we come across clusters that are above this threshold. So we don't want within a cluster to have dissimilarity above this threshold. So what that'll do is it'll give us two clusters. Let's have a look at them. There's our first cluster and there's our second cluster. And that makes sense. So what that is telling us is that within each one of these clusters, the dissimilarity is always less than our threshold. So let's say we've got some values here. Let's say this is 1.5, this is 2.0. So let's say we want to set the threshold at 1.7. And what this is doing is it is not allowing any clusters that would have dissimilarity of greater than 1.7 within them. And as you can see from the dendrogram, we can tell that everything below that level, this cluster and this cluster, they don't have dissimilarity of 1.7 because dissimilarity is represented by these vertical lines. And that's how the concept of thresholding works. And the interesting part about dendrograms is you can quickly tell how many clusters you will have at a certain threshold by just looking at how many vertical lines this horizontal threshold actually crosses. So here you can see it crosses 2 vertical lines. That means we will have 2 clusters. It will be this cluster with all these points, P1, P2, P3, and this cluster P4, P5, P6. All right, so let's have a look at another example. Let's have a look at an example where we put the threshold at this level. So somewhere just below where we combined, as you remember, we had P5, P6 in one cluster, P2, P3 in one cluster, P4 by itself, P1 by itself, and then we combined P1 with this cluster, P4 with this cluster. So let's say we're setting the threshold at just before that level of dissimilarity, which allowed us to combine P1 with this cluster and P4 with this cluster. So what that will do is it will give us a certain number of clusters. So can you tell just by looking at the dendrogram how many clusters we'll have? Exactly correct. We're going to have 4 clusters because it crosses 4 vertical lines. 1, 2, 3, 4, right? So we're going to have a cluster P1, cluster with P2 and P3, cluster with P4, cluster with P5 and P6. Let's have a look. 4 clusters, and there they are. So that is what we're going to get if we set the dissimilarity or distance threshold at that level. Let's try another one. Let's say we want to set our dissimilarity threshold very low at 0.3, meaning that we don't want clusters that have any points within them that have dissimilarity greater than this threshold. So we're not going to allow any clusters like that. And the interesting part here is that we're actually setting the threshold below our very first cluster that we created over here, P2 and P3. So we're not even going to allow P2 and P3 to be combined in one cluster. We're going to say that dissimilarity level, that distance between them, is too great, too high. We don't think that, based on our business knowledge or based on our other internal research or external research, that we don't think that any points with dissimilarity greater than this level should be combined into a cluster. It just doesn't make sense from a business perspective, from a perspective of knowledge about what this data set is about. And what that will do is it will create 6 clusters because we cross 6 lines, 1, 2, 3, 4, 5, 6, and there they are. Every single point will be in its own cluster. As you can see, we've got 6 clusters. So that is how a dendrogram works, or how you can get value out of a dendrogram, and you can set this threshold at different levels to understand how many clusters you'll get. Just by looking at the dendrogram, you can tell right away, and you can that way find the optimal level for the threshold, or the optimal number of clusters that suits your project the best. So, but how do you find the actual, not just an optimal number of clusters that you think is optimal? What is the dendrogram giving us any ideas about the optimal number of clusters? What can we tell from the dendrogram that might be a good guide for us to select the optimal number of clusters? Well, there's a great giveaway that the dendrogram contains, and that is the vertical distance, because it is measuring a dissimilarity. So one of the standard approaches is just to look for the highest vertical distance that you can find on the dendrogram. So basically any line that will not cross any horizontal lines. So for instance, this line can be considered. This line can be considered. This line cannot be considered for that research because it crosses hypothetical horizontal lines. So what you need to do is kind of like every horizontal line you have, just imagine it extends all the way across the dendrogram. Every single horizontal line you have. And now find the longest line among your existing vertical lines that doesn't cross any of these extended horizontal lines. So for instance, even this line cannot be considered for that purpose because it would hypothetically cross this horizontal line that we have coming from this red line between P5 and P6. Again, this line cannot be considered because it's crossing this line. So you would need to look at this line, for example, or this line, or if you wanted to use this line, you would need to use only a bit of it, that part or this part. So you can only use parts of lines that are between horizontal lines. So out of all of the lines that you have here, which is the longest that doesn't cross any extended horizontal lines? Well, that's correct. This one over here is the longest one, or basically in our example, the green and the red, they were about the same height. So this one or this one are the longest ones. And so this is the largest distance, and therefore the best or the recommended approach, again, it's not a set in stone approach. It's kind of one of the things that you could do is take a threshold that will cross this largest distance. So cross that largest distance with a threshold, and then use that threshold to calculate the optimal number of clusters and actually find them. So once we've crossed this largest distance with our threshold, it doesn't matter where you set it. You can set it here, you can set it lower, you can set it high, as long as it crosses this line. Then now the two clusters are this one and this one. As you can see, that is considered to be one of the approaches, or this approach is telling us that the optimal number of clusters is 2, and these are them. And kind of in this case, it makes sense. You can see that indeed these points look as if they're closer together, and these points look as if they're closer together rather than getting any clusters in between them, or even breaking up into more clusters wouldn't make as much sense as this makes sense. And so there you go. That's one of the approaches that you can use. You can still look at this whole problem using similar approach to k-means, where you use the elbow method. So you could use something like that. But in hierarchical clustering, we're going to focus on this approach with the largest distance. And now let's quickly have a knowledge test. So I have two charts here which are hidden. On the left, we've got the scatter plot. On the right, we've got the dendrogram. I'm going to show you only the dendrogram, and I'd like you to try to understand or try to assess very quickly what's going on the scatter plots. So for instance, we'd like to know, even without seeing the scatter plot or the dataset at the moment, we'd like to know what is the optimal number of clusters in this dataset just by looking at dendrogram. Can you identify that? So if you like, you can pause the video and just look at these vertical and horizontal lines and try to find out, based on the method that we discussed, what would be the optimal number of clusters. So in 3, 2, 1, I'm going to now reveal how I would solve this challenge. Well, what I would do is I'd look for the longest vertical line that doesn't cross any extended horizontal lines. So if you extend that, extend that, extend that, you can see that it's probably this line over here. And so that's the largest distance. And that means we need to cross it with a horizontal line with our threshold, and that will give us the number of clusters, which is 3 clusters because it crosses 3 lines here. 1, 2, 3. And if we look at the chart, as you can see, indeed, we do have 3 clusters, and it does look like that is the optimal number of clusters for this business problem. So hopefully you enjoyed this tutorial. We walked through all of this manually so that you have a better intuitive understanding of how the hierarchical clustering algorithm and dendrograms work. And next, Hadlong will show you around in R and Python, and together you will create some amazing analysis around hierarchical clustering. And together with him, you will solve a business problem using the hierarchical clustering algorithm. You've got some fun tutorials ahead of you, and I look forward to seeing you next time. Until then, enjoy machine learning.